All right, this is the no calculator FRQ. I'm going to try to do this all in one shot. This problem is very much just a conceptual understanding of the relationship between derivatives and integrals and antiderivatives and paying attention to detail. That's the other thing. Okay, so it says a particle moves along the x-axis so that its velocity at time t for t between 0 and 6 is given by a differentiable function v whose graph is shown above. So key thing, right, to start with is that this is velocity, right? Okay, that's important. All right, the velocity at 0 is 0 at t equals 0, so it's what it looks like at t equals 3 and t equals 5. So these are all zeros, just like it looks like on the graph. And the graph has horizontal tangents at t equals 1 and t equals 4. So like right here, there's a local minimum, and here there's a local maximum. What else does it say? The area of the regions bounded by the t-axis and the graph of v on the intervals 0 to 3, 3 to 5, and 5 to 6 are 8, 3, and 2 respectively. So this is 8, 3, and then this over here is 2. These are the areas between the curve and the x-axis. And at the time t equals 0, the particle is at x equals -2. Most people missed that, including me the first time. So that's something to pay attention to. That last thing is important because you start seeing the problem, you start to think, oh, I think I know what I'm doing. You start thinking about what kinds of questions you're going to be asked and how you're going to solve them, and you forget to pay attention to this detail, which turns out to be very important. And a lot of people just lost points just because of that. Okay. So what is the first question? Oh, first thing to think about is that this is the velocity curve, right? So what do 8, 3, and 2 represent? They are, well, 8 is equal to the integral from 0 to 3 of vt dt. Well, that equals 8, and that the integral of the antiderivative of velocity is going to be the displacement. So we know that over this time, from 0 to 3, this particle, which appears to be going back and forth, left and right, goes 8 units in the negative direction. We know it's negative because this is negative here, and then this is, we can think of the displacement then as -8. Okay, then the integral from 3 to 5 of vt dt equals 3. So that means that after it got out here, it moved 3 units back. And then the last part says that the integral from 5 to 6 of vt dt, that equals 2. That's this area over here. So once it got to this point, it moved back 2 units. All right, so let's draw that out a little bit more carefully now that we know what we're talking about. All right, so we've got starting point right here, and it moves 8 units in this direction. Then it moves 3 units back, and then it moves 2 units. Do it a little more carefully. 2 units this way, so not all the way back to that farthest point. Okay, this is important. The other important thing that's easy to overlook if you miss this last thing at the end is that it started out at t equals 0. It starts at x equals -2. So if this is x equals 0 over here, it actually starts out 2 units over from whatever 0 is. For whatever reason, that's what they're calling 0. Okay, so this is important. For part A, it says when t is between 0 and 6, find both the time and the position when the particle is farthest to the left. Justify your answer. Well, when it's farthest to the left is going to be right here, because it never gets all that way back. It goes 8 units this way, 3 units back in the positive direction, and then 2 units back in the negative direction. But if it goes 2 units, it's never going to make it back to here. So where is it? So where does it, so how long is it, sorry. So when does it reach here? Well, it reaches here. We know that that's when, if we go look at our graph, that's right here when t equals 3. So for part A, we should get when t equals 3, x of t, or the displacement of t, of the particle, is going to be here, which is, now a lot of people would say, oh, it's -8 because I've gone 8 in the negative direction, but you have to remember it started out 2 already in the negative direction, so it's a total of -10. All right. So part A should be t equals 3, x of t equals -10. Part B, if you missed this thing about it starting at x equals -2, it's also going to screw you up on part B, right? Because it says, part B says, for how many values of t where t is between 0 and 6 is the particle at x equals -8. Well, most of you, and this is how I started out with, I thought, oh, well, it's at -8 just this one time because I was thinking that this was 0, right? I was thinking, oh, this is x equals 0, so here's -8, and it never makes it back there, so it just goes there one time. But that's not right. -8 is actually where? Well, it's about here. So let's see. Let's make sure we're clear about where it goes, right? So it starts out at -2. It goes -8, so it gets to right here, which is -10. Then it goes back 3 units, so that's going to put it at -7. And then it's going to go 2 units more, so it's going to end up here at -9. Well, how many times does it cross -8? -8 is right in here between -7 and -9, so it crosses it once, twice, 3 times. All right. Try not to make a Lionel Richie reference there. Okay, once, twice, 3 times, so it crosses it 3 times. And you know how you justify that? You can say, well, it's once on the way out, once on the way back, and once on the way again. And you can maybe draw a diagram. Any of those things are going to make it make sense. Okay. But again, if you missed this thing at the beginning, then it's going to mess you up here and here. All right, part C. On the interval 2 to 3, is the speed of the particle increasing or decreasing? Give a reason for your answer. This is a tricky one, and it messed people up, I think, because it's kind of hard to figure out what they're asking. They're asking, is the speed of the particle increasing or decreasing? Now, they're not asking, is the speed of the particle positive or negative? If they asked you that, it would be, well, it would be negative because it's below the x-axis here, right? Between 2 and 3, yeah. So we're looking at between 2 and 3. So right in here. Well, that whole time it's less than 0, right? Up to 3, not including 3. It's less than 0, so you think, oh, the speed is negative. But that's not what they ask. They say, is the speed of the particle not negative or positive, but increasing or decreasing? That is it getting bigger or is it getting smaller? And we can see it goes from here when it's, I don't know, what is it there? It's negative, but we don't know what it is, right? But it's something less than 0. Here, v is less than 0. And up to here, v equals 0. So what happened? Well, it got bigger. It increased. So our answer to part C is it's increasing because, and I would say, because v of 2 is less than 0 and v of 3 equals 0. All right. That one could be a little bit confusing too. During what times, in part D, sorry, during what times, if any, is the acceleration of the particle negative? Well, acceleration, let's use is there another color we haven't used yet? What about this one? Yeah. Okay. Acceleration is the change in time, change in velocity over time, which is to say it's the slope of the velocity graph. So we're looking for where the slope of the tangent, or dv dt, the slope of the tangent, we're looking for where the acceleration is negative, so we're looking where the slope is less than 0. Okay? So we have to go back up here now, and we look and we say, okay, well, it's less than 0 from here all the way down to here. That's from 0 to 1. And then from here all the way to 6. So from 0 to 1, and then from 4 to 6. So we're going to have our answer would be 0, 1, and like this, 4, 6. Hopefully that's what I put too, isn't it? Let's look at the paper. Oh yeah, good. That's actually what I wrote. Okay. And you can, this would be your explanation as well for your answer. All right, so that is the no calculator question.